Hi, I'm going to say about Advanced Data Mining Project by James Weeks and Bhargav Reddy Babba. I'm talking about unsupervised learning. In unsupervised learning, we discussed about task, data preprocessing, sampling, clustering techniques. This is the unsupervised process diagram using DB scan. And this is the continuation one. And we also used unsupervised learning using k-means. The first phase of the rapid miner operates are for the data preprocessing, which includes normalization and bootstrapping from sampling of data. Using multiply operator, k-means DB scan cluster operators are used to achieve the model results. For the data set A, the number of items found by the k-means clusters are 1000 plus, where for the data set E is 4,85,269. Here is the visual representation of the data sets A and B clusters. For the data sets A, there are 11 clusters and are given for the average of the distance of the data points in that cluster from the centroid of the same cluster. And the same goes with the data set B. And this is also the same for the k-means cluster for the data set A. And this is the sample, this is the output result for the cluster A, k-means cluster tree. And this is for the cluster tree for the data set B for the unsupervised learning. For the DB scan, the data set A consists of 25 clusters from DB scan, and for data set B has 40 DB scan clusters. Given are the absolute count for the data points in the cluster and the fraction of the clusters in the total DB scan clusters. DB scan clusters are more compared to k-means because DB scan can find more sharper clusters. The important task that includes in unsupervised learning or the snippet data preprocessing part. And coming to the meta learners, this is the rapid miner diagram which I got it. And coming to the bagging, for the leftmost is the sample data set A and the rightmost is sample B results with accuracy of 98 point. And for the data set B, the accuracy is 91%. For the Bayesian boosting, the accuracy is 99. And for the data set B, the accuracy is 92. While go with the voting boosting, I got 98.48, and for the accuracy for the data set B, it's 92. For the random forest, the accuracy is 98.20, and for the data set B, the accuracy is 92, which I forgot to mention it. And this is the bagging results from the set A. And when compared to the results, the best sample, the sample A was Bayesian boosting with 99.0% accuracy. The best for sample B was random forest with 92.42. Sample A has a holdover better accuracy when compared to the sample B set.
For the simple rule-based and associated learning, we did the data processing through data discretion, and we did 3 models: the rule induction to generate the sample rules, and then we did the FP growth for the association rule generation, and then validation, k-fold cross validation, where k was set to 10 folds. And here we have the setup for the rule induction, the associated mining that we used. And the output of that set, both data set A and B. And here's the cross-validation, the rule induction using cross-validation. And we can see on the next slide the results for that. And then using the FP growth.